so now we're going to do a problem where we're putting Professor Hafner to work. Are you ready? We've got Professor Hafner, and he's pushing two masses along a surface where the coefficient of friction is 0.44. We're looking for, so mass 1, we've got our givens. Mass 1 is 111 kilograms, and mass 2 is 66 kilograms. We are looking for how hard Professor Hafner has to push to accelerate these masses at 0.33 meters per second. So the second part of the question asks, what is the force that M1 pushes back on Professor Hafner? So the first thing we always have to do is we look at our equations. We know that if we see the sum of the forces, then we're probably going to have to draw a free body diagram. So we have the sum of the forces equals ma. We have the force of friction equals mu f normal, and that Fg equals mg. So let's take a look at our free body diagram and see how we set up this problem. So we've got these two masses. We'll just put them together for the first part of the problem. We know they go, there's a force of gravity down and a normal force up. We know Professor Hafner is pushing, and we know the force of friction is pushing back. And the force of friction is smaller because we know that we have an acceleration. So let's check out how we're going to set this up. Our solution is, we've got the sum of the forces is equal to the mass times the acceleration. So what are our forces? Up and down, we know we're not accelerating in the up and down direction. So we know that these two are balanced. We'll use that in a minute. So we've got the applied force, Professor Hafner, minus the friction force slowing him down is equal to the masses times the acceleration. Clear? So since we're looking for the applied force, we're going to pull this friction force over, and we're going to look at what it looks like. You know me, I like letters more than numbers, so we're going to do m1 plus m2 times acceleration. Then we add this friction force over here, but I'm going to change it because I know what it is. I know that friction is mu times Fn, and I know that Fn is equal to Fg. So I'm going to pop in mu Fg for both of the masses. Okay, now I feel like we can put in numbers. Hope you do too. We get m1 plus m2, which you actually see in two places, is 177 times our acceleration, which is 0.33, plus mu, which is 0.44. I'm going to go ahead and put those two together. 177 times, we'll use 10 meters per second squared for g. Put that into your calculator, add it up, and you get that the applied force of the professor on the boxes has to be 837 newtons. So we'll say, we'll call it F prof is 837 newtons. Now, the second part of the question asks, how hard does this M1 push back on Dr. Hafner? If you've been watching your lecture videos, you know that because the system is closed right there, M1 has to push back on Professor Hafner with the same force, equal and opposite. So it's by Newton's third law, M1 is pushing on Professor Hafner with the same magnitude of force, just in the opposite direction. So we say F M1 is equal to 837 newtons. Hopefully that will remind you how to work some of your sum of forces problems, and it'll remind you about Newton's laws. Hope that helps with your homework.